welcome to Fast Talk, your source for the science of endurance performance. I'm your host, Trevor Connor, here with Chris Case. If there's one overlooked area where most athletes could still make substantial improvements to their training and performance, believe it or not, it's the gut and the immune system, which are inextricably linked. The immune system, which relies on appropriate inflammation, is responsible for training adaptations and the effectiveness of recovery. But it takes a delicate balance. Inflammation is critical, but if there's too much, or if it spills into the rest of our body, it can be very damaging. It can also hinder our ability to fight infection. As I hinted at, the gut and our immune system are intimately connected. In fact, 70% of our immune cells live around the gut. So when the gut microbiome stops functioning well, so does the immune system, which disrupts our ability to adapt. As most endurance athletes eventually learn, long efforts can be very tough on the gut. The damage endurance exercises causes can impact the immune system, which harms both our ability to adapt and recover. In other words, if we don't manage this tricky balance between a healthy gut, the immune system, and adaptation, the exercise we do can actually become one of the biggest hindrances to our ability to adapt to that exercise. So it is critical that we talk about this balance and how to manage it. Here to discuss this is Dr. Chaleff, a board-certified interventional cardiologist. Over 35 years of working with patients, Dr. Chaleff has discovered the value of proper nutrition and lifestyle as a first line of defense. His company, Cimera, focuses on physician-formulated supplements backed by a large body of science to help patients find optimal health. Our conversation with Dr. Chaleff will start with an explanation of the immune system and how the gut functions. It goes deep into the science, but we'll use that science to get into the good stuff, including how a healthy gut and immune system aids training, why endurance athletes get more colds and what they can do to avoid them, and tips to reduce GI issues, including some of the dietary approaches that have proven to be helpful. The digestive and immune system are two of the most complex systems in our bodies, but they also impact everything we do, including our training and performance. Understanding them is important to all of us. So, get some probiotics and get ready to digest some deep science, and let's make you fast. Listeners, come ride with us. Now through March, Chris Case and I are hosting Zwift rides every Tuesday with special guests like Neil Henderson, Brent Bookwalter, Dr. Steven Seiler, and more. Each workout will be an easy, no-drop ride so you can chat your cycling training questions to our experts and get interesting answers, all while getting a 1-hour workout. Register for Fast Talk Labs Zwift rides on Zwift.com or see our guest list and register on fasttalklabs.com/Zwift. Well, Dr. Chaleff, thanks for joining the show.
Thank you for having me here. It's a pleasure. Looking forward to it.
So any of our listeners who have been listening for a while probably already figured out that I am excited about this episode because we're about to talk about the immune system. We're about to talk about the gut. We're going to be talking about IL-6 and Th17 and all these things that...
He gets giddy when he talks about this stuff.
We're going to have some fun. This is going to be an exciting one.
And I can tell that Dr. Chaleff is giddy too. He's got a big smile on his face. So this is going to be an interesting conversation.
Oh, yes. This is great stuff to talk about.
Chris, you're going to have to keep us under control.
I'll try.
Dr. Chaleff, you are a doctor who has been working with patients for years. You research this, you study this. So couldn't ask for a better guest to have on the show to talk about how the immune system functions in athletes, how it relates to the gut and gut function, because that's really important in athletes, and some of the things that we can do to keep everything functioning well.
It is so true. And I think, a lot of my patients, and maybe even athletes to some extent, I just think they don't take the gut, or maybe perhaps should understand it more, and how important it is to so many bodily functions. That symbiotic relationship between all the microbiome in your gut is so important for muscle adaptation, the brain, immune system health. It's incredibly important. And people, I think they overlook it a little bit too much, in my opinion.
So we're going to get there and we're going to dive into this, but let's start with the most basic question, because I know you hear in the media all the time, inflammation is bad, you don't want it, which isn't totally true. Could you give us just a real simple, basic one-sentence definition of what is meant by inflammation?
So inflammation in the broad term is basically, not always, but related to immune system response most of the time. You can get inflammation related to toxins or tissue damage. The response is somewhat similar, And there was a lot of overlap. But basically, inflammation occurs and the body responds to this inflammation in order to repair body tissue or fight infection.
And you hit a really important term there, because I think this is another really key thing to understand as we go through this is repair. Because we're talking to athletes right now, and athletes are training, they're doing damage to muscles and to tissues. And then your body repairs that damage. And the whole idea of adaptation is it then repairs it back bigger and stronger and better. And it's the immune system that does that, right?
Absolutely. Now, when you damage muscles, when you exercise, cycling or long distance running or Olympic training, whatever the case may be, you need to get these little micro tears and damage to the muscles. Then you have to rebuild. And it's inflammation that's part of that process. Now, if you mitigate or prevent this inflammation from occurring, you're not going to build. Then on the other hand, when inflammation gets out of hand, you cause the damage. And sometimes that body tissue doesn't heal and grow as fast as it should, because its overwhelming inflammation will prevent that from happening. So you have to have that balance of just enough tissue damage, inflammation, repair, adaptation. Now, a very interesting thing about muscle adaptation is that these micro tears that you get, you have to facilitate the healing and the growth. But there's an important component is the vascularity that's involved with it as well. And when you dive deep into this, a lot of this comes from the myokines that are released from the muscle when you get the damage. And that's very important as well. And I don't know if you've talked about myokines in detail before.
I just gave Chris a big smile because I'm like, we're already getting into the fun terms.
Yeah, let's define myokines for those who've never heard the word before.
So a lot of science-related people have heard cytokines. These are proteins or chemicals released from cells. Myokines are similar proteins, but they're released from the muscle. The muscle has an autoregulatory component of these myokines that help the muscle adapt. And it's a balance between sometimes these myokines and these cytokines that come from the inflammatory process that help the muscle build and adapt. Many different types of myokines. IL-6, as commonly mentioned, is one. Another myokine that's very common is called BDNF. And BDNF is called brain-derived neurotrophic factor. Even though it's in the muscle, it's called BDNF because it was first discovered in the brain. But what BDNF does at the muscle tissue level is when you're undergoing the adaptation, it maintains that neuromuscular connectivity, as well as when the angiogenesis develops, we get new blood vessels to supply blood to the new adapted tissue so it can grow. It's very complex. Matter of fact, IL-6 is the muscle's natural anti-inflammatory. Then you get the IL-6 that comes from T cells and the site of inflammation that becomes pro-inflammatory. So you have this balance here. But a good athlete's adaptation always wins.
Yep. IL-6 is one of those, whenever you read anything about the immune system and inflammation, you know IL-6 coming up.
Yes.
And as you said, sometimes it's anti-inflammatory, sometimes it's inflammatory.
Yes.
It is such a complex protein.
And it's released from many cells in the body. And that's the thing. So it's the overall interaction, too, with the other chemotactic factors. But it's very important that you have the angiogenesis and the new blood vessel growth to provide to the muscles to help the adaptation process, like we said.
You know, also, as you said, this inflammation in the muscles is really, really critical. And there was a time when we felt, oh, after you exercise, you're getting this inflammation. We need to get rid of the inflammation. And people were taking NSAIDs and they were doing icing and all this. And recent research is showing that was actually hurting the repair process. That was causing damage in the muscles. So that's something you want to avoid. You want that inflammation to happen after you work out.
Yes, yes. And people don't realize it's actually a good thing. But what happens sometimes is I think the way this issue of inflammation and trying to resolve the inflammation happened is that sometimes you can't go out the next day because you feel sore, which is actually a good thing. But people want to be able to go exercise the next day. So, oh, let me take this and feel better so I can go exercise. But that's actually counterproductive sometimes. Now, a very low-level athlete, maybe not, but high-endurance athletes, cyclists, runners, that's very important to get that muscle adaptation. And it varies for everybody too, genetically. Some people adapt much faster than others. And that's because the level of these myokines and other cytokines vary from person to person. And it is genetically programmed by certain genes that we have.
So there's more here than just the immune system, though. The gut is intimately tied to this. So let's talk about how the gut and the immune system are intimately linked.
Yes.
I'll start out. Another really important thing for everybody to understand is about 70% of your immune system lives around the gut. There's a huge relationship between the gut and your immune system. So talk a little bit about that and how that looks when it's functioning well.
So that's a good question. To understand the basic pathophysiology of what goes on in the gut, yes, it makes everything a little more understandable. Just to put it in perspective, it's hard to know for sure, but it's been estimated to be between 38 to 100 trillion microbacteria in your gut. No one knows for sure, but that's an estimate. And when you add the total amount of all those bacteria in your gut, and there's also viruses, believe it or not, and there's yeast, and there's many, many strains. There's maybe hundreds of 1,000 strains, actually. 30 to 40 strains are the most common. And we see that probably make up at least about 95 or so plus percent of the strains, 30 to 40 of those strains. If you add the total amount, all the microbiome probably weighs about 2 kilos of weight, maybe 4 to 5 pounds. And there's this relationship between this good bacteria and the toxic bacteria, and they balance each other out. They each have these byproducts where they feed off of each other. They provide each other with nutrients, but you need to keep the good in check as well as the bad in check as well. It's a symbiotic relationship. When you get this dysbiosis, we call it, where there's an imbalance, then you start to get this whole response at the cellular level between the cells that connect, the endothelium there. At the cellular level, you get inflammatory response where you start to get tissue swelling, the mucous membrane. And some bacteria, by the way, that just help synthesize this mucus that protects the lining. When that starts to break down because of this imbalance, then you get all these byproducts of metabolism that break down that can get into your bloodstream. And those are very pro-inflammatory, sometimes at a low level. And people don't even realize it. You get fragments of nucleic acid. You get lipoproteins that get in there, lipopolysaccharides that get in there, and toxins that get into your bloodstream. And that causes low-level inflammation. To make it even further more complicated, you have lymph tissue throughout the gut. We call them, especially in the ileum, it's called Peyer's patches. And you have this infiltration of T cells, both on the regulating side and on the suppressor side, that keep these in check. And this is kind of a back and forth mechanism to keep the bacteria from growing or entering and causing an adverse effect on the mucosa in the gut. So it's highly complex.
Yeah, this is really complicated. And unfortunately, we're just touching on the surface here. But for anybody who's new to this, just to put this in really simple terms, we have billions of bacteria in our gut. Some are good, some are bad. They all interrelate and they connect to our immune system. If we just keep them in the gut, then they can be beneficial to us. But if it starts breaking down, if the balance gets wrong, if they get into our bodies, then they cause inflammation. Then they cause all sorts of issues like dysbiosis that you were just talking about, just excessive inflammation, and that leads to all sorts of problems.
From a layperson's perspective, maybe this is relevant. There's always a sort of pro and a con. There's a balance here. There's things that are good, things that are bad. From an evolutionary point of view, why is there always this balancing act taking place amongst these complicated systems? What's the purpose?
Well, so before you dive into this, let me just give a little bit here as some background. One important thing to understand about this bacteria in your gut is we talk about there's good bacteria, bad bacteria. It's all bad bacteria if it gets into your system. It's good when it's in your gut.
Sure.
But if it gets past the lining of your gut and gets into what's called systemic circulation, then it's all bad.
Where you get bacteremia, sepsis, that is correct.
And your body wants to deal with that. But going back to what you're saying about the evolutionary side, this is the way bacteria, viruses, they all evolve. We're their home, their host. They want to find a good relationship with us. And so over billions of years, bacteria has evolved a symbiotic relationship where we give it a good moist home, we feed it, and it gives us beneficial things in return.
And you have to realize we cannot control what we consume and the bacteria in what we consume. So then nature takes care of that balance kind of over evolution. And some of the toxic bacteria do provide nutrients in their metabolism that the good bacteria actually feed off of. And that's with a symbiotic relationship. And that's how that evolved. But it took many years how that process happens. And it's little by little. So it never gets out of hand where it becomes toxic.
There are some bacteriologists who say that humans don't run the world. Bacteria runs the world. They just made us to give them a home.
Well, actually, they were there before we were.
Yep.
So, I guess we owe it to them.
Yes.
But yeah, it is very, very complex and we can't function without it.
Yeah. But you mentioned, and this is something that we'll probably bring up a few times, you mentioned lipopolysaccharide, LPS. We've mentioned that on the show, and it's a really important thing for people to know about because it is a marker on gram-negative bacteria, which is generally considered the bad bacteria. And when your body starts detecting it inside your body, so in systemic circulation, alarm bells go off. And that's when your immune system starts reacting and reacting very strongly.
Absolutely. It triggers a significant immune response. And yes, a lot of the gram-negative bacteria have these lipopolysaccharides, and it can become toxic response. And it can overwhelming sepsis. Your blood pressure will drop, your blood vessels dilate. And this is a cascade that happens where you can die. So it's very serious. Now, we have the gram-negative bacteria in our gut. But like you said before, Trevor, it's kept in check. The mucosa protects the intestines. There's a barrier to entry. They do provide nutrients for other bacteria that helps produce certain chemicals. The vitamin K and neurotransmitters are produced from the help in the gut, from tryptophan, serotonin, things like that actually help in the brain-gut axis as well. So we do have it, but there is the balance and it is kept in check in your gut. But yes, if it gets in your bloodstream and you get septic from it, it could be really serious.
So one particular immune cell that I want to talk about very quickly is dendritic cells. There are a ton all around your gut, and they're these little cells that have these very long arms that can kind of sneak between the epithelial cells in your gut and get into where all the bacteria is, and they just kind of sample what's in there and see what's going on. And most of the time they just go, yep, all the bacteria is in the gut, we're fine.
Yeah, they don't get triggered.
They don't get triggered. But if you have a leak, so people talk about leaky gut, that's when you see a breakdown in the protective barrier and the bacteria starts getting in. And then the dendritic cells go alarm bells and mobilize a huge immune response.
Yes, it starts the cascade. Macrophages, T cells that get mobilized. There's a lot of chemotactic factors that get released. Can cause local inflammation. It depends on the extent. And then you get the junctions between the cells, the epithelial cells start to break down. And yes, that's when you get this leaky gut. And there's variations of leaky gut. It can be very mild where you don't know that you can't even have it. And sometimes you get this low energy level, or you just have this kind of delay in even fighting cold sometimes gets delayed because you have this underlying inflammatory response, or tissue healing becomes delayed. And that's because of this additional burden of inflammation due to a leaky gut. And that's when there's the dysbiosis between the good and bad bacteria start to develop. And again, sometimes it's this low-level inflammatory response. In fact, we can even check in the blood. There are some blood markers for that. We call it C-reactive protein, which is an acute phase reactant. And sometimes we can see a level of inflammation. Sometimes it's just mildly elevated. And a lot of doctors just say, well, it's a little elevated. We'll just kind of keep an eye on it. And maybe it was from this leaky gut that was happening. And it can be from other things as well. But sometimes we have to think about, is this a leaky gut in patients that do have these kind of problems, especially low energy? We see that a lot. To rule out other things, of course.
But there is a ton of research showing that chronic leaky gut can precede a whole lot of conditions, particularly autoimmune conditions.
Oh, yes, that's a very good point. Yeah, and the autoimmune, what happens is that's another type of inflammatory response where you get these particles that get into the bloodstream. And sometimes there's a similarity between the makeup of the particles and the body recognizes as foreign. And then on some of your body tissues, there is a similar makeup. So your body starts to attack your own tissue because of that exposure to that sort of protein or lipopolysaccharide or some other component that's very similar. And you can get self-destruction of your body tissues. Also, what happens in autoimmune, you get these immune complexes, and then your organs become innocent bystanders to these immune complexes, where the immunoglobulins start to bind together, but they become, let's say, a big molecule, goes to the kidneys, can't get filtered out, and just causes damage to your kidneys, for example. And that can also happen as a result of certain autoimmune problems.
Yep. And then there's one other piece to add to that, to the puzzle, which is Th17 cells, which you were talking about mobilizing T cells. Th17 cells are a highly inflammatory cell that are designed to address when bacteria gets from your gut into circulation. Th17 cells come in and address them, and they've shown chronically elevated Th17 cells precede pretty much every single autoimmune condition. It's almost a necessity for development.
Right, and that's part of the pro-inflammatory process is when you see the Th17, and you need the inflammation to help fight infection or whatever the case may be, inflammation there. But remember, it is balanced by the T suppressor cells too, but sometimes it becomes too overwhelming, and then you have the destructive process that gets out of hand. But under normal circumstances, you get the T17 and the Treg cells that kind of keep each other in check. But the initial is definitely overwhelming T17.
Yep. Told you this was going to get fun, Chris.
Science.
Yeah. Now, by the way, if you really want to get fun, there is something called the ROR gamma T. This is really for the people who love science. ROR gamma T is called the retinoic acid orphan receptor. This is what helps regulate some of the T17 cells, and how the T17 responds sometimes is receptor related to by the ROR gamma T. And on the other hand, there's something called the FOXP3. FOXP3.
You're just making this stuff up now.
No, I swear, this is the real deal.
I know the FOXP3.
Yeah, I'm kidding.
And that's called Fortet, believe it or not, because it looks like a Fortet on the cell when they look at it at this very high level. And anyway, that also is what affects the Treg. That's a gene. And it's so important that they were actually looking at the chemotherapy at the FOXP3 gene and all these receptors as cancer research too. So these are very important. And it's fun to read about, actually, because it makes a lot of sense when you read about ROR gamma T and FOXP3 and how it affects the regulation of T17 and T suppressor cells.
I loved it when I was studying immunology. I created a big chart of all these different chemicals and names and finally just had to stop.
Yes.
It got so big.
And it doesn't end. It's like you go from one thing to the next and another chemotactic factor. And this affects this. And then you have this cell and that's it. For immunologists, I have to give them credit. They have to have a lot of patience. That's why I love cardiology. It's a lot more straightforward
Yes.
when you have the blockages. And by the way, we do get inflammation there too in the heart and the lining of the cells. And there is bacteria there also sometimes. But I have a question for you guys. Cyclists, do they really learn, you think, enough, like when they're competitive cyclists, you think they learn enough about the gut and know how important it is in your conversation with a lot of your colleagues?
Well, so once again, you anticipated where we wanted to go because that's exactly what I wanted to talk to you about. I love this because, Chris knows me. I read a ton of research coming into this one because this was like being in a candy shop for me. And there's a relatively new study called Exercise-Induced Gastrointestinal Symptoms in Endurance Sports, a review of pathophysiology, symptoms, and nutritional management. And they talk a lot in this study about how much GI issues impact endurance athletes. And it was surprising. Like they cited one study where it was something like 70% of the people that had to pull out of big endurance events, it was because of GI issues, because they're having gut issues. And so you see in endurance athletes, a large number of them saying, I have all these GI issues. So they know that it impacts them. They know it's making them pull out of events, but they have no idea what's causing it.
That's a great point. So the thing is what happens to most athletes, they get ischemia in the gut. So what happens is the gut is not an important organ when you're doing high level performance. So the blood is rerouted to the muscles or wherever you need it, not to the gut. Well, when you keep going on, you get more and more ischemia. And then what happens is this starts to affect you where you feel inside, and you just can't go because you might feel nauseous, maybe get abdominal pain. You think it's lactic acid, whatever the case may be, but sometimes it's ischemia, and that's why you have to stop. So if you don't have this proper symbiotic relationship, and then you start high endurance training and you start to get the ischemia, that's going to predispose you to gut problems even sooner. So a lot of athletes get that ischemia in their gut, and they probably don't even realize that's what's happening. The blood is getting rerouted to the muscles from the gut, and that's what's affecting them.
Yeah. So in this study, they talked about that. They said there were kind of two pathways, the neuroendocrine GI pathway, and then the circulatory GI pathway, which is what you're talking about, and just how damaging this can be. And it goes to, so we were just talking about some of the issues you can have in the gut. And basically what they said is it leads to three things. One is intestinal permeability. So it's that breakdown of the barrier, release of LPS into the system, and ultimately that leads to inflammation. So talk a little bit about that in athletes, because I mean, that's not what you want.
No. So what happens is, let's say your microbiome in your gut is not in optimal condition. Okay, there's a little dysbiosis there. Maybe not to the level that you would realize it. So there may be a small level of leak or inflammation there that may be even subclinical, undetected. Now what happens is you start to train and you're not, let's say, hydrated enough, for example. The blood flow to the intestines becomes compromised, which is normal. But now, because of this ischemia component, the small, let's say, low level of dysbiosis that you may have had in your gut becomes more prominent, more prevalent. And now you may have more symptoms sooner. And that's what leads to the leaky gut transiently at that point. And then you start to get all these toxins, LPS in your blood, and then there's an inflammatory response. And then your muscles become inflamed as well. So now you have the local inflammation from muscle use, and you're adding systemic inflammation on top of that, which affects the tissues. Plus you have the ischemia to your bowel, which is uncomfortable. And let's say you didn't hydrate the way you should. All this comes into play. You'll never finish your routine. It'd be impossible, or keep up. Either way, you start to slow down. And all this has to do with training too. You do train your gut for that transient ischemia also. But again, that microbiome has to be optimal ratio. The aerobic, anaerobic, yeast, all that has to be optimized to perform well.
Yeah. And to that point, that review that I just mentioned talked about you have greater diversity in the microbiome in elite athletes, and diversity is better. So there's alpha and beta diversity. I don't know if we want to go into those, but you have better diversity in elite athletes, and that can prevent a lot of the issues that you have during exercise. And another one I found, interplace between exercise and gut microbiome in the context of human health and performance. Same thing. They just said in elite athletes, they can avoid a lot of these issues, a lot of the permeability, because they have a better microbiome profile than sedentary individuals or people who aren't very fit.
And, and that naturally evolves as they train too, because a lot of good athletes, they'll have the right diets and all that, maybe like the sauerkraut, so things like that provide yogurts that provide additional bacteria. But if they do, that will help them train better and get their gut in even better shape. There's a probiotic component to the yogurts and to the sauerkrauts and things like that, which is important.
What about a probiotic? Can that help?
Yes, the right probiotic will make an incredible difference, because the right probiotic will have the proper balance between aerobic and anaerobic. Number one, you need the right ratio. You just can't take one that say, okay, we'll give you a little bit of this and a little bit of that. There's certain ratios that's in your gut, and your probiotic needs to emulate those ratios in your gut to make it optimized. And also, when you take a probiotic to get this optimal microbiome in your gut, we presently feel that it needs to be in a delayed release capsule, so it gets released in your duodenum and not destroyed by the acids in your stomach. So you get improved deliverability. And of course, it should have the prebiotic as well. So all these come into play. And if you want to really do it right, you have to have some component of yeast in there as well. We like Saccharomyces because that's in your gut as well. And that's part of the symbiotic relationship.
Yep. Interestingly, in this one review, they talked about that a lot of the supplements really don't have the diversity in it, only have a couple forms, and it's the diversity that you need.
So think about this, Trevor, Chris. Okay, it's 1,000 strains in your gut. 30 to 40 are the most common strains, maybe 95%. Well, why are you going to take a probiotic that has one strain or two strains, and who even knows what amounts of those strains they have of that in their probiotic? It doesn't do anything. So there's a lot of science and data about specific bacteria in your gut for specific reasons. Bifidobacteria, lactobacillus, Saccharomyces boulardii, this is a yeast, Rhamnosus GG, all those things have a certain function and provide nutrients to each other to optimize the microbiome environment in your gut to prevent that leaky gut. That will make a difference in an athlete, especially a high endurance athlete.
Well, here's right out of this review. They did a probiotic supplement for 28 days before a marathon race with athletes. So it's Lactobacillus acidophilus, Bifidobacterium bifidum, and Bifidobacterium animalis. And it said it was associated with a significant lower incident and severity of GI symptoms and limited decrease in average speed in the probiotics group.
Yeah. So it goes to say the microbiome, the gut, the environment, the small chain fatty acids, the neuromuscular connections, the gut-brain health, all that has to come into play. If you want to really perform, you have to be optimized. It's not just about hydrating and taking a protein bar and then taking your protein when you're done for your muscle recovery, whatever technique routine you had. While you're performing, you need to really have everything in order. And that's a major component. People take that, I think they take it for granted. I know they do in my practice. They take that for granted as well. I really don't think they look enough into it. Maybe because they don't understand it.
Yep. Mm-hmm. So I know we've gotten complex with the gut and the immune system, but let's get it even more complex because there's actually this axis here of the gut, the immune system, and the brain. So talk about how this all impacts the brain as well.
So because the gut and the microbiome is so important, as a result of the metabolism of all these different bacteria, you do get certain neurotoxins that actually, some form that are released into the bloodstream. And these neurotoxins do get into the brain. And there has been some implication here that these molecules that get into the brain may be implicated in memory dysfunction, cognitive dysfunction, Alzheimer's, autism, multiple sclerosis, Parkinson's, depression. So even the intact gut is important, not only for muscle adaptation and immune system, but also the brain and the gut and all the possibilities like how it can affect your brain if it's not healthy. And it goes back to maintaining that healthy gut, not having that leaky gut syndrome where you get these adverse toxic components that can even get into the brain.
Obviously, diet plays a role here. You mentioned antibiotics can throw things out of whack in the gut. Are there other things like anti-inflammatory, ibuprofen, these types of things? Are there any other things that can throw the gut biome out of whack?
Anti-inflammatories can actually be very damaging to your gut and increase permeability. So I would be careful about those.
This is why I ask, because I think that a lot of endurance athletes are often taking these things because they have the aches and the pains and, they're training hard and their knees might be going, so they will take that stuff, not understanding the consequences.
Yeah. Any one of those things that alter the pH, for example, they alter the way the bacteria function and reproduce and metabolize will alter that symbiotic relationship. And sometimes we don't know which meds do what at that level because there's really no way to study. But we do know that, yes, the anti-inflammatories, especially in your gut, are definitely not healthy. If you want to get the good adaptation, you really shouldn't take much of the anti-inflammatories anyway, because that's counterintuitive to what you need to achieve. But, sometimes it's painful. You can't stop. So they want to take a little bit. But you just got to work through the process.
Yep.
Mm-hmm. So going back to antibiotics, what that does is, okay, let's just say you have an infection, sinus infection, for example, and you go ahead and you take your antibiotics for your sinus infection. Well, you're ingesting this antibiotic. It will get into your bloodstream. It will prevent or fight the sinus infection, but it's also going to kill the good bacteria in your gut. The bad bacteria is somewhat more resistant to this because there are a lot of anaerobes that this mechanism of action doesn't affect them as much. So what happens now is you destroy the good bacteria. The bad bacteria, the pathogenic bacteria will proliferate. They tend to produce a lot of toxins. Well, this will destroy the lining of your stomach. And sometimes it forms a membrane that is so intense, we call it, looks like a membrane, pseudomembranous colitis, and they get massive diarrhea because the fluid gets from the tissues into the lumen of the intestines. And then you just cannot stop this diarrhea because the fluid just comes out constantly. And that's because the good bacteria were destroyed in your gut from the antibiotics. The pathogenic bacteria were able to proliferate, releasing toxins and other metabolites that cause the gut to swell and leads to a cascade of events. In fact, it gets so bad that you can actually die from it.
Mm-hmm.
The toxins that are produced from that. Pseudomembranous colitis is early part is called antibiotic-associated diarrhea. And then it can lead to what we call toxic megacolon, where the colon swells and this membrane-like structure forms because of what's happened on the surface. And yeah, it can be super serious. So antibiotics are not a simple thing. You have to be very careful and take it for the right reason. However, if you take the probiotic, hopefully it does less of a problem.
Mm-hmm.
And talking about diet, something that you see a lot of athletes do is switch to what's called a low FODMAP diet,
Mm-hmm.
which can relieve a lot of symptoms. But the issue with it, and I'll let you take it from here, is it's also very low in fiber. And having good amount of fiber in your diet is really important to a healthy microbiome.
Yes, because they actually digest that fiber and they use it for energy, and the remnants of the fiber breakdown is used for the other bacteria to live off of. So it's a part of the symbiotic relationship. And that's part of the prebiotic that you put in probiotics, which helps feed the whole process. You want to have good prebiotic as well when you take your probiotic to help facilitate the process. Now, I wouldn't be surprised if some people out there, they go train and they're on antibiotics sometimes for whatever reason, and they want to train. But my gosh, that could be a toxic combination when they start doing things like that. So they have to be really careful and not to push it.
One other thing I want to quickly throw in, and please respond to this, but you're talking about diet, and I think this is important to mention for anybody that's having these issues, particularly leaky gut issues, is some grains, particularly wheat. You have two things that you have to be aware of. So everybody's talking about a gluten-free diet. In gluten is something called gliadin. Gliadin causes a release of something called zonulin in your gut, and zonulin opens the tight junctions of your gut, so it really causes leaky gut. Different levels of susceptibility in people, but something you have to be careful of.
Absolutely true. Yeah, and people don't realize that. That's a good point.
Yeah, well, I'm sure you're familiar with all the work of Dr. Fasano. I mean, it's pretty extraordinary what he discovered with that. And then the other one to mention that you also get in some grain products are what called amylase trypsin inhibitors. You definitely find them in wheat. And we were talking before about the dendritic cells, which kind of reach into the gut and are constantly sampling. Amylase trypsin inhibitors bind to the dendritic cells and set off the alarm bells. And it's an inappropriate alarm because there isn't a bacterial invasion.
It'd be like a false activation.
Right. So this is my theory. A lot of people talk about, I go to Europe and I have the breads and I'm fine, but when I have bread here, it really bugs me. What is the difference? In America, they discovered these amylase trypsin inhibitors and discovered they were actually a really good natural pesticide. So the wheat over in America has been bred to have very high levels of amylase trypsin inhibitors, which you don't see in the European wheat. And so one of the theories here is you have much higher amylase trypsin inhibitor levels here, and that's setting off these immune responses.
Yeah. And again, every individual is so different, with some may be more sensitive than others. And it goes back sometimes to this genetic predisposition, just like with the T cells and the ROR gamma T and the FOXP3. Who knows to what variation people have these responses in their T cells as well. But in that case, with the dendritic cells, that's another component and process that can promote dysbiosis and dysfunction and leaky gut. It's a very interactive play between so many variables. And in order to train properly, you have to really do a lot of research and learn. It's not that easy if you want to be serious about it.
Yeah, no, it's tough.
What if you could optimize your nutrition to perform even better in your sport? Well, you can. I'm Jared Berg, and I'm a registered dietitian and exercise physiologist with Fast Talk Labs. I can help you with your personal sports nutrition, or you can take control of your own nutrition through my new 8-week sports nutrition course. Learn more at fasttalklabs.com. Look for athlete services and sports nutrition.
So do you find that some of the people that you know tend to get more colds or whatever the harder they train? Do you ever hear any of that among your peers when they talk?
I got to say, you're the best guest ever because I have not had to make a transition yet to follow our outline. Every time I'm like, okay, we need to move on to this. You ask us a question, it's like, oh, that's exactly where we're going to go. I'm loving this.
Sometimes I just think of that, the immune system. I'm just wondering what your colleagues, your athlete, your friends, your high endurance athletes are saying. Hey, am I getting a lot sick when they train hard? You ever notice that?
You get that all the time, particularly in high-level athletes. They're just like, I'm sick all the time. I don't know why. And I'll throw this to you, but just there was this great study that looked at these elite endurance athletes and when they were getting, so upper respiratory infections. And they were looking at those and then looking for viral causes and found an actual viral cause in less than 50% of the cases. And we're basically saying there just doesn't seem to be a virus related. They have the infection, but we can't find a virus that's causing this. So I'll throw it to you, but this is one of my favorite things about the immune system in endurance sports.
So we know that athletes, when they train hard, their immune system is suppressed. And that's very natural because you're putting a lot of physical demand and it takes functionality away from the immune system to try to optimize your performance. But as a result of that, you get a decrease of interleukins. We call this, I think it's the open window period of infectivity, where for that short period of time, you are definitely more susceptible. There's about 3 to 6 hours where your immune system definitely reaches a low until it kind of gets back up to normal. Now, you can get a cold sometimes because you're more susceptible, but some people feel like they have a cold and they don't. Like they may get the runny nose. And you get the runny nose for a lot of reasons. There is bacteria in your nasal mucosa, which sometimes can start to proliferate and causes inflammation. And then they get a runny nose. Sometimes it goes to the back of their throat. They feel like they're getting sick. And then they start to recover and then their immune system kind of kicks in. They never really get sick. And there's no virus and there's no real bacteria. And that's what kind of really happens. It's low level of inflammation that makes them feel sick, but it's bacteria that's normally there that they start to proliferate because the immune system gets weak. Sometimes the IgA that's in the mucosa can't keep up just yet. And then as you hydrate and relax, interleukin levels go back up. You can fight it and suppress it, and then just pretty much resolves. Sometimes if you're too tired, you get too weak, it will evolve. And sometimes it could be a virus also. And a lot of guys too, when they train, they breathe heavy through their nose. And this movement of air causes irritation to the mucosa and a local inflammation as well. And they get a runny nose. You ever notice, let's say you go up north and you go skiing, let's say, and your nose just starts to run?
Mm-hmm.
Well, that has to do, it's part of the little inflammatory process and the vasoconstriction of vessels and then everything that happens that causes that. You're not sick, but that's an inflammatory response there to some extent, mediated by temperature. Sometimes they feel like they get sick, they're mediated by local toxins in your nose or throat, or sometimes it's allergens or whatever the case may be. And for those athletes that feel they get the runny nose, I feel like they're getting sick, they really don't, and there's no viruses there. Some of those people are very susceptible. We tell them to put Vaseline or water-soluble gel around the nasal openings to help mitigate some of that are related to the high breathing through their nose, for example. So little things like that. But if you do get sick, that is because, and a real cold, that is because your immune system was suppressed and you were exposed during that open window, most likely.
Well, so something I think really important to mention, this was some of the most interesting research I've read in a long time, is there's something called systemic inflammatory response syndrome, SIRS, in athletes. You were talking before about how when we do a lot of damage from exercise, it's the immune system that sparks a response. And you brought up IL-6, which can be both anti-inflammatory and inflammatory. The body goes, yeah, I need to activate the immune system to go and repair local damage, but it would be really bad if that then spilled into the entire system and went systemic.
Sometimes it can get out of hand. Yeah.
Right. And so that's part of the reason your immune system gets suppressed after exercise, because it's trying to keep it localized to where the damage is. But that doesn't always work well in people, and it does spill out into the system, and that's that SIRS. And I read a study where you saw extreme cases of this, where you're essentially seeing endotoxemia in athletes where it had gotten so bad they ended up in the hospital.
Yeah. That's kind of like you can see it in an immune response for anaphylaxis. It can get so bad you can end up in the hospital. It's somewhat, somewhat related to that. And that sometimes is genetically predisposed on the way your immune system responds to inflammation as well. Just to give you an example, your immune system response sometimes dictates what happens. And we even see this in patients with hepatitis. Why do some people get a fulminant hepatitis, while some people get a low-level form of hepatitis? Some of that has to do with this, your body's immune system response. Well, that's the same concept. Depends on our immune system response. It's systemic, overwhelming, hyperreactive, depends on a lot of things. But yes, all immune system mediated. And sometimes it's a little unpredictable too. You can't really predict. And you never know when you're going to reach that threshold either on certain people. Sometimes if you keep pushing yourself, that might throw you over too.
Yeah. So here's my question to you, and I'm saying this somewhat knowing your answer because you sent me some really interesting studies on beta-glucans. But are there ways that we can find this balance of allowing the muscles to do their repair, not have this SIRS response where it gets systemic, but also still keep the body able to fight infections? It seems to be a really tricky balance between those three things.
It is a tricky balance, and you basically have to know your body. And I'll give you an example. You train hard. You cause muscle damage. You want to facilitate that adaptation and keep growing and growing on it. But at the same point, you don't want to overdo it where you start causing damage. So in general, there's a general rule that you want to take a few days to heal, let the adaptation process evolve, let the inflammatory process evolve, get that adaptation, muscle growth, a repair of the micro tears, the angiogenesis process evolve, and then move on. So you really have to know your body and train. That's the main thing. Now, it's a funny thing. A lot of this stuff sometimes is more localized than you realize. For example, a lot of the myokines, they're all over, but there's a high intensity of myokines that is sometimes released, believe it or not, in your calves, the gastrocnemius and the soleus muscle. Now, even though it's all over, there seems to be a higher proportion there for various reasons, I guess evolutionary reasons for whatever, I guess as we're evolving. And sometimes you feel it in one muscle, I guess depends where you use it as well, and not in other muscles. And that's, again, sometimes a myokine release is different in one set of muscles than the other. But you have to learn your body and know how to train, know how long it takes to get that repair. And usually it's a day, a few days. If not, then you're going to affect the adaptation process. And if you work too hard, then you're going to get more of a systemic inflammatory response than you will an adaptation inflammatory response. And then there's the concept of there's inflammation from your immune system, and then there's inflammation from the free radicals that develop when you work out also. And that's a whole nother concept of inflammation from free radicals, reactive oxygen species, and inflammation as well. There's a balance there too.
Yeah, that is a whole nother conversation that I've been debating whether we even want to bring it up. But tell us, just share this, because I was really surprised by this. And I read most of the studies you sent me about beta-glucan.
Yeah, beta-glucans. Okay, there's many different types of beta-glucans. And the beta-glucans is known to stimulate the immune system because certain beta-glucans, for example, a 1316 beta-glucan, has a pattern recognition that's similar to lipopolysaccharides. And we all know what lipopolysaccharides do. So what happens when you take this 1316 beta-glucan, the body sees it as a lipopolysaccharide. Well, what does the body do when it sees a lipopolysaccharide? It activates the immune system immediately. So your innate immune system responds immediately to this. So what happens is now your immune system is primed when you take the 1316 beta glucan. And then if you ever get exposed to a pathogen or whatever, a virus, a bacteria, whatever the case may be, your immune system is primed to clear that so much faster than if you didn't take the 1316 beta glucan. Now, we say 1316 because that's the repeating structure, molecular, that somewhat is similar to the lipopolysaccharide that we find on many toxic pathogens. Now, not all beta glucans have that similarity to the lipopolysaccharide and will not stimulate the immune system. For example, I think oatmeal has the beta glucans that will not stimulate your immune system.
It tends to be yeast derived.
Exactly. Yeah. Baker's yeast and a few yeasts, exactly. And actually, there's a couple of mushrooms, believe it or not, that actually have it too. The beta glucan that has the lipopolysaccharide similar component will stimulate your immune system. Yeah, mushrooms and baker's yeast are the big ones.
Yep. But here's what shocked me. I actually looked this up after you sent the studies to me. It was like, this has to be a bad thing because, as you said, it kind of acts like LPS, so it's going to stimulate an immune response. But what's the response to LPS is elevated Th17 cells. And the reason we brought those up earlier is because chronically elevated Th17 is a really bad thing. It precedes autoimmune conditions. They've now related it to cancer. I actually just downloaded in the fall a really interesting study that said that this seems to be related to neurodegeneration and Alzheimer's disease. So one thing you don't want is really elevated Th17. So I went, wait, this is not something we want to put in our body. So this is a study, and laugh at me for how I pronounce this. It just came out last year, effect of Saccharomyces cerevisiae beta-glucan.
Saccharomyces cerevisiae, yeah.
Thank you. Beta-glucan on the T helper cytokine profile. And what they showed is it stimulates the innate immune system, as you said, which helps fight pathogens. It stimulates Th1, which is our dominant response to pathogens. But they did not see any elevation in a Th17 response.
That's exactly what I was going to say. Yeah. And that's because when you take this, it's more of the innate immune system than the adaptive. And the innate immune system is where you have acutely, the adaptive is more on the chronic side. And we found, based on these studies, that it was the innate immune system that was activated and the adaptive was pretty much spared. And that's what you're looking for in this case.
And so they were saying, as opposed to actually promoting cancer, this is being explored now as potentially an anti-cancer treatment.
Yeah, that is so true, because what they found when they did the research on some of this, when they looked at the 1316 beta-glucan in some of the research, they wanted to give it to cancer patients who were constantly getting sick. And they found how it worked, whereas more the innate than adaptive. In fact, it works so well, in Europe, they put it in the infant's formula as well to help boost their innate immune system while they were evolving and developing their own immune systems. So yes, it was definitely, the data was more innate than adaptive. And that's why it's not a problem with the T cells.
Yeah.
I mean, there's always a little crosstalk, but it's usually it's not a major issue. That's good information.
Yeah. No, I was surprised and fascinated by it. So
in fact, they did studies that showed that endurance athletes, runners, had fewer colds when they took the 1316 beta-glucan, and they recovered from their colds quicker. Their fever score was less, and their symptoms were diminished.
yeah. And they overall felt better. That was one of the studies you sent me. It was shocking the level that you saw the improvements.
So when we look at products, we know when we do the research on this, we only recommend the 1316 beta-glucans. Now, the oats with the beta-glucan is good for your cholesterol, but when you talk immune system, it's the 1316 that makes the most sense, based on the data too. A lot of research on that.
So I know this is opening a whole new can of worms, so maybe we just get a broad overview, but it wouldn't be appropriate to talk about inflammation, particularly in athletes, without talking about oxidative stress, because as endurance athletes, we produce a lot of oxidative stress, and that can promote inflammation in our bodies. So just maybe give us the 4 or 5 minute version of this.
So oxidative stress occurs usually at the local level. And athletes, consume a lot of oxygen, of course, as they're functioning and performing. But what happens is at the local level, you have a lot of oxidative metabolism going on. Well, as a result of that, you develop what's called free radicals. The chemicals, the oxygen, it gets a little technical here, but it has a negative charge, for example, and is looking to combine with a positive charge to neutralize its instability. So this free radical oxygen binds with a positive component on your cell membranes that are there. Well, as a result of that, it causes a toxic effect to the cell membrane and further promotes the inflammatory process. So this is inflammation that occurs at the cellular level as a result of reactive oxygen species looking for a charged component to neutralize itself. Well, that happens to be your cell membrane, and that causes inflammation in itself. Once it does that, it disrupts the membrane. And then you get a whole nother cascade. So what happens is the athletes have inflammation at the local level from the reactive oxygen species, the free radicals from the metabolism of the oxygen, and that will promote the systemic effect of inflammation on top of that. So they get hit from both sides. That's basically what happens there.
But throw a little complexity here. They've identified kind of 4 main triggers of adaptations in endurance athletes. So we've talked on the show, and we won't go into these, about the calcium comodulin pathway, several of the main pathways. But oxidative stress is one of them. You need some oxidative stress to adapt, and they've shown that taking too much antioxidants can actually blunt training adaptations.
Yeah. And the thing is, remember, the inflammation that occurs is part of the adaptive process. You get the inflammation from the reactive oxygen species at the local level with a metabolic level, and you can get it from the systemic. So yes, you will get and you need that for adaptation as well. It is one of the components, because that's probably happening first and you don't even know it sometimes due to the high oxygen level consumption, whole process.
I'll ask you the same question here that I asked for inflammation. How do you keep the balance? So getting enough oxidative stress that you adapt without getting so much oxidative stress that you're causing health concerns?
That's a tough question because you can't really measure it on the microscopic level at the cellular level. It just really depends on how you feel. You're always going to get oxidative stress, always. The systemic response will depend on how hard and how you push yourself. So you just pretty much have to know your body. You can't really take anything to reduce this balance between reactive oxygen species, oxidative stress, and systemic inflammation. There's no way. It's just the way you feel. And to understand these things are going on in your body and push yourself to a point where you're not going to cause damage, but just enough to where you're pushing the muscle to its limit. Because remember, you are getting these micro tears. And you want those micro tears. And you need those micro tears to adapt. And sometimes when you stop, the inflammation process will somewhat slow down. And so will the reactive oxygen species pathway slow down. So you just have to know your body. That's the way you find the balance.
So now I have to ask, Chris, have we sufficiently confused and baffled you? Or
No, you haven't confused or baffled me. I can't speak for everyone that's listening, but I think there is a way to bring this back to, and we will in our take-home messages, why this is so important and what is the key message for athletes to take away from this. We'll get there.
Mm-hmm.
Hang with us.
But maybe before we get there, so Dr. Chaleff, we've owed this to you. Tell us a little bit about your company. I really liked the story of how you came up with your company and what it is that you do.
That's a funny thing, Trevor. It's a very interesting pathway because as an interventional cardiologist, I was very cut and dry. This is the science. This is what we do. And everything we do is really outcomes driven. So patients will come to me and they say, I really don't want to do this. I have arthritis. I have GI gut issues, my immune system, whatever the case may be. And what could I take? And they will come to me and they would say, no, you don't. No, that's not good. That's not going to work. There's no data there. There's no data. Then along that pathway, we started doing clinical research for this company. And they asked me to review the data, go through the medical literature, and see what works, for example, for gut health, probiotic. Well, we did quite extensive research. It was over a year, several years, going through all the literature, talking to companies, looking at what's clinically researched. And we found that, yes, there is data to support a benefit. However, when we developed our products, for example, that we took the data for the specific strain and to the point where it was the genetic strain of a certain bacterial strain. And we looked at that data and we saw there were true outcomes benefit. And we used that data to develop the products. But the interesting thing was that data was very specific. It says it's this strain, it's this genetic component of that strain, and it's this amount that showed efficacy. And that's what we went and used, that specific information, and used that in developing our products. So each, for example, our probiotic, each one of the strains, and remember there's 30 to 40 of the most common strains. Well, we have a total of 18, and those were the most common of the most common. But we developed the product based on the data that shows each strain has a certain amount that's proportional to what was shown to be effective and can relate to the proper symbiotic relationship in your gut. We chose anaerobic bacteria, aerobic bacteria, and the Saccharomyces, because that's the data that showed efficacy. We put all that together, and that's how we came up with our specific probiotic, which is probably the only one that I know that emulates the right dose and the right efficacy of what's in the gut, and has a combination of aerobic and anaerobic. And you won't see that in a lot of different products, specific the way this was targeted based on the research. And we did the same thing for the immune system with the 1316 beta-glucan, like we were talking about, because that's where the data led us to.
Well, this is what I really liked about your story, which is you sell supplements, but you don't sell every supplement under the sun like a lot of companies do. What you've done is, as a doctor, you looked at the issues that you were seeing patients deal with, going into the research and saying, what has been proven in the research to help? And then those are the supplements that you offer, the ones that have demonstrated efficacy. And I really do admire that, because you go to your website, you don't have a giant list of supplements, but it's lists of ones that you could say, here's 100 studies that show the benefits of this.
Yeah. And it's so specific. If an individual wants a specific study on a specific strain, we have that data. And as a doctor, I'm just not going to recommend, I'll go take this over there at one of your local drugstores. No. As a doctor, the patient expects me to recommend something that has efficacy and proven, something I would take myself or give my family. And that's how our products were developed, with that in mind. That was the guide for the products to work. And now when I give it to my patients, and some of them don't need it, of course, but when I feel they need it, say, this is what you need to take for this specific reason. And I can tell you, I just want to say this, but we have this probiotic we use in some hospitals around the country, even as far as Alaska, for patients who have problems with their gut in the intensive care unit. And we even have to ship it out there like overnight. Well, it doesn't get overnight to Alaska, but as soon as possible, because they depend so much on it. It has really excellent efficacy. And I'm telling you, for endurance athletes, you'd be surprised to have the proper probiotic to maintain the proper symbiotic relationship in your gut will make a huge difference over the long term.
And I liked what you were saying before, that you feel some doctors go to surgery too quick, go to medication too quick, and you're really trying to see, is there a step before that where we can help you through a more natural means first?
Yeah, and there's a lot of history in some of the natural medicines out there. I mean, the Chinese have been doing it for ages. It doesn't work for everybody, for everything. And sometimes you have a serious problem, you got to do what you got to do. But yeah, there are options out there, and I'm okay with that, as long as I know that there's some efficacy and clinical data to support the use of this stuff, and not just take it to sake of just try this and see what happens. I mean, sometimes there's an incredible placebo effect. I mean, patients will take things, oh, this worked great, and I look what's in there, I go, there's nothing in here. How does it even work? Well, whatever. I said, okay, but excuse me, you don't need to take this anymore. You're fine. You know what I mean? Okay, it's like, there's some stuff I hate to get in there, but stuff that's made by teachers that they sell. Like, okay, there's nothing in here that really worked. What the heck? I'm like, okay.
Yes.
And the placebo was better than the product effect. But yes, so everything that we did was based on, as best as possible, evidence-based data with efficacy and outcomes. And we do have the studies to prove it. And then I know as a doctor, I can recommend something and feel good about it, that I just did the right thing. And it's better for the patient, of course. One of our products is Symune. It is excellent when people get exposed. For example, they travel and they get potentially exposed to a high volume of individuals where they think they might get a cold or infection, like an event or a convention or whatever, a movie theater. And I always take that before I even get on a plane. I feel very good about that one too.
As I was saying off mic before this episode, after reading all that beta glucan research that you sent to me, I ordered some off of your website.
Yeah, exactly. And you're going to love it. As a matter of fact, I gave it to a neighbor the other day. And she was coming down with a cold. She goes the next day, she felt so good. She went out and bought 3 boxes for her mother to take back. She's from Russia, believe it or not, to take back to Russia in case she gets sick. So, yeah, it's really good stuff. And well, it's good data to prove it. And that's why I like it.
You know, I could go another how many hours on this subject?
10 rounds.
We
10
probably
rounds.
could. But I think we'll call this one a day. So first time on the show, we always finish with what we call our 1-minute take-homes. So each of us will have 1 minute to give our final message, the most important message that you feel the listeners need to hear. And we don't have a timer, but you have 1 minute. Would you like to go first or would you like to go last?
You guys go, that's fine. I can go last.
I can't compete with either of you guys, so I'm not sure I have much to say besides it's complicated, but it's important. And I think your point, Dr. Chaleff, early on, actually posed as a question. Do a lot of endurance athletes think about this? And I think the resounding answer is not really, no. Even despite the fact that a lot of them will experience GI issues in their lifetime, or in some cases, they will experience it frequently. They just don't connect this subject with that outcome. But as we've displayed here, it's complicated, but it is very important. And it seems like in some ways, there's a few simple things, foundational things that can help with so much of the, maybe reducing the cascade of effects, negative effects, whether it's to GI distress during events or the immune system function or some of these other auxiliary side effects of having poor GI microbiome function and its place in immune system function.
So I'll go next and I'll let you finish it out. There's a bunch of different messages I could give, but I think to me, the one I want to offer is that there are areas of science where there's still new research coming out, but it's just minor changes on or additions to what we already know, and you don't see something that exciting come out very often. When you are talking about the gut, the immune system, health, how they all interrelate, there's exciting new research coming out every day. This is just this amazing area of research that we still have so much to discover. And I think so many ways in which it can help athletes. Because, yeah, if you're having gut issues, that really is going to affect your ability to perform. If you are having aberrant inflammation, that's going to affect your ability to recover. So I think this is actually a really important area where athletes can see a lot of improvement, and it's something they often don't think about. And so, Dr. Chaleff, we'll let you finish us out here.
So I think those are excellent comments from both of you, but my real important takeaway is this, is don't take the gut for granted. Like you mentioned initially, Trevor, 70% of the immune system really starts in the gut, but the gut-brain axis, the gut-muscle axis, the gut inflammation axis, all that is interrelated. That all has to be optimal in order for you to maximize your performance. Your muscle adaptation will reach its optimal effectiveness when all that is in order. So the right probiotic for the right gut health will make a difference. you probably don't even realize that you need this, and you will notice the difference if you take this and optimize your immune system function, your adaptation function, the gut-brain axis function, angiogenesis for proper muscle development, the blood flow, and the proper balance between suppressor and regulatory T-cell function at the muscle level. You have to balance the fire on all cylinders. So that's the takeaway. Don't take this for granted.
Perfect.
Great answer. Thank you. That was another episode of Fast Talk. Subscribe to Fast Talk wherever you prefer to find your favorite podcasts. Be sure to leave us a rating and a review. Don't forget, we're now on YouTube. Give us a like and subscribe there too, and help us reach new audiences. As always, remember that the thoughts and opinions expressed on Fast Talk are those of the individual. We love your feedback. Join the conversation at forums.fasttalklabs.com or join us on social media at FastTalkLabs. For access to our endurance sports knowledge-based continuing education for coaches, as well as our in-person and remote athletic services, head to fasttalklabs.com. For Dr. Frederick Chaleff and Chris Case, I'm Trevor Connor. Thanks for listening.